this video, we'll discuss about minimum number of swaps to make the string balanced. So first, let's understand the question. You are given a zero-index string S of even length n. The string consists of exactly n by 2 opening brackets and n by 2 closing brackets. A string is called balanced if and only if it is the empty string, or it can be rewritten as AB, where both A and B are balanced strings, or it can be written as opening bracket C, closing bracket, where C is a balanced string. You may swap the brackets at any two indices any number of times. Return the minimum number of swaps to make S balanced. So what they are saying is that you are given a string in your input which always is even length, and it will always contain n by 2 opening brackets and n by 2 closing brackets, right? And this string can be balanced or can be unbalanced, right? You need to return that how many minimum number of swaps are required to make this string balanced. Now, what is a balanced string? So whenever we write an opening and closing bracket, if I write them in this format, then they are always balanced, right? But if I will write them like this, that this, right, or this, then these are not balanced, right? So in this entire string, you need to check that all the brackets should be balanced. And if they are not, then you can perform the swap. And you need to perform minimum number of swaps to make your string balanced, right? Now, so if you see here, these two, if you see, these are already balanced, as I told you, right? Now, but these are not balanced. But if you will swap these, then it will become this, right? So now these are already balanced and these are also balanced, right? So now this becomes a balanced string. So we performed only one swap. So now the concept is, now let's suppose you are at a closing bracket, okay? And you know that let's suppose there are two opening brackets before this closing bracket, which are unmatched. Means there are two opening brackets before this which are not matched with any other closing bracket here, right? So you can say that I can match one of these brackets with this closing bracket, right? So most probably you will use the last opening bracket that is unmatched and you will pair it with this, right? So now when you will pair this with this, your number of unmatched open brackets will be reduced by 1. And then later on when you encounter a closing bracket again, which is not matched yet with any other opening bracket, then you can pair this one with this one, right? And your string will be balanced. So whenever we are at a closing bracket, we see that if we have an opening bracket before it, which is not yet matched with any other closing bracket, right? So now, if you see for this example, if I start from here, my opening brackets are 0 right now, right? Then that means for now, I cannot pair this closing bracket with any other opening bracket. Then at this point, again open is 0, I cannot pair it. At this point, again it is 0, I cannot pair it. Now at this point, your opening bracket becomes 1. It is not yet matched with any other closing bracket, right? So open will become 1. When you will come here, your open will become 2. When you will come here, your open will become 3. When you will come here, your open will become 4. Now when you will come here, you have encountered a closing bracket and you know that I already have 4 opening brackets before it which are not yet matched. Then we can use one of them and pair it with this closing bracket. So if we use the last one, with this closing bracket, we can pair them, right? So we will decrease the open by 1. Now, when you have traversed this entire string, you saw that at the end, there are three open brackets that are left, which were not matched with any other closing bracket. Then that means this string is not balanced, right? If you take an example of this string, so here you will see at this point, your open will become 1. At this point, open will become 2. Now, when you will come here, this is a closing bracket. So you will match it with some opening bracket. You know there are two opening brackets available. So you will pair one of them with this. So now these will get paired. So you will reduce your open by 1. Now when you will again come at a closing bracket, you will pair it. So now you know that there is one opening bracket that you already have. So you can pair this with this. So now your open will become 0. Now, when you have traversed this entire string, your open is 0, then that means we were able to match all the open brackets with the closing brackets. Then that means this string is already balanced, right? So now, this number of open brackets after the string iteration is telling us that whether our string is balanced or not. But our requirement is what? We need to return the minimum number of swaps needed, right? So if in this case, if in this string, if you see that, if I swap this 0th element with this 4th index, then what will happen? It will be like this. Right? Now, this is balanced, this is balanced, this is balanced. Now only these are the brackets that are not balanced yet. So now if you swap these two as well, then your string will become like this. Right? Now this is balanced, this is balanced, this is balanced, and this is also balanced. So now this unbalanced string is converted to a balanced string. And how many swaps did we perform? This was the first one and this was the second one. So total of 2 swaps we performed, right? And our open brackets were 3. So keep this thing in mind. Now if we come at this string, what you will do, you see, these are already matched. So if you swap these two, then you can get your answer, right? So the swaps that it needs is 1, right? After doing that, you will get this string. Now, if you see that, if we iterate in this string, then how many open brackets we are getting? So when you are at this point, your open is 0, right? So it cannot be matched. Then you come here. So now your open becomes 1. Then you come at a closing bracket. You can match it with this open bracket. So now open will become 0. Then you will come at this opening bracket. So your open will become 1. So now when you have traversed this entire string, you know that the total number of open brackets left unmatched is 1, right? And the swaps here needed were also 1. So if you closely look, see, whenever we are going to swap the brackets, right? Whenever we are doing the swapping operation, then what is happening that each swap will fix 2 brackets, right? One is the unbalanced opening bracket and one is an unbalanced closing bracket, right? So our minimum number of swaps will be what? Half of this, half of whatever we have gotten, right? To understand it more clearly, if we take one more example, if let's suppose I have this type of string, right? I have this string, right? Now if you see here, I'll keep the indexes as well. In this case, when you are at this point, your open is 0, here also open is 0, here also open 0, here also open 0, right? So till here, open is 0. Then you come here, your open becomes 1, right? Then here your open becomes 2, here open becomes 3, here open becomes 4, here open becomes 5. Then you encounter a closing bracket, so you decrease this by 1. So open becomes 4. So at the last of this, you have total of 4 open brackets. Now how can you perform minimum number of swaps on this to make it balanced? So now if you pair this 0th index with the 7th index, then what it will become? It will become like this, right? This will be like this. So now this is balanced, this is balanced, this is balanced. Only these are not balanced, right? Now if you swap these two, right? If you will swap these two, then your strings will look like what? This, this, and this, right? So now if you see that all of my brackets are balanced now. So how many swaps did we perform? 1 and 2, right? So 2 swaps we perform. So when our open was 4, we performed 2 swaps. When our open was 3, we performed 2 swaps. And when open was 1, then we performed 1 swap. And as I told you that each swap will fix 2 brackets, one unbalanced open bracket and one unbalanced closed bracket. So now here, the minimum number of swaps will be what? Half of this, right? 4 by 2 is 2. But in cases where we have odd number of brackets, right? Odd number of open brackets, in that case, we'll do open plus 1 divided by 2, right? Because although the first 2 will get adjusted by 1 swap, but for the other remaining odd number, we have to perform 1 swap, right? So that has to be included anyways. We cannot ignore it anyhow. So open plus 1 by 2 will give us the minimum number of swaps that are needed to balance the string. So in this case, your 4 plus 1 divided by 2, which is 5 by 2, so it will be 2. So 2 swaps. Here 3 plus 1 divided by 2, which is 4 by 2, so 2. So 2 swaps. And then here 1 plus 1 divided by 2 is 2 by 2, which is equals to 1. So 1 swaps. Okay. I hope you got it. So now let's code this. So first of all, we'll create a variable open, which will keep the count of the opening brackets that are not matched yet. Okay. Then this is a variable n, which will store the length of our string. Now we will iterate in our string from index 0 till n, right? And now what is the character? We'll check. Let's suppose I keep it in ch. Now if I'll check that, if this character is an opening bracket, right? Then that means this opening bracket is not yet matched with any other closing bracket, right? So I will increase the open by 1, right? Else, if it is a closing bracket, right? Then what I'll do? I will match one of the open brackets with it. But I can match only when I have a open bracket available to me, right? So only if the open is greater than 0, I will match an opening bracket with this closing bracket. So here, if open is greater than 0, then we'll do open minus minus. We will decrement one opening bracket. And at the end, we will return open plus 1 divided by 2. So now let's run this. So if you see here, we are just looping in our string ones. So this will be a time complexity of order of n, right? Our test cases got accepted. Now let's submit this. So it got accepted. Thank you so much for watching.